In this example, we're going to look at how to write the equation of a straight line given 2 points. It's a pretty standard question, and we're going to list it both in slope-intercept form and in standard form. And as an added bonus, we're given a couple points with a lot of negative numbers in there, so we get to practice how to subtract negative numbers. Okay. Now, depending on the type of information you're given when you're trying to find the equation of a straight line, it normally always comes down to the first thing you want to do is find the slope, and then once you have slope and a point, you're good to go. So no matter what they give you, your goal is always to find slope and have a point. Sometimes you're given a point and slope and you're already at step one, let's say. Sometimes you're given a point and another line and they say find a line that's parallel to this line or perpendicular to this line. Well, they've pretty much given you slope just in a roundabout way, because you know if they're parallel, both lines have the same slope, and if they're perpendicular, it's opposite reciprocals. So just remember that no matter what information you're given, your job is to first find the slope and then use the slope and a point to find the equation of the line. So if you use that information, that set of rules, that recipe, so to speak, then given these two numbers or these 2 points, the first thing you want to do is find the slope. And you'll remember that slope is very simply just change in y over change in x, right? Call it rise over run if you want, but the formula is y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. It doesn't matter in what order you go. You get the same thing. That's the nice thing about slope. The slope of the line doesn't change if you're going from left to right versus right to left, right? Think about walking up a hill versus walking back down the hill. It's the same slope in both directions, right? So it doesn't matter in which direction you go to calculate this slope. Okay, so all we know is we're going to find the difference in our y's. So we're going to have to use the two y numbers. And it's going to be one of them minus the other. And then when we go to do the x's, it's going to be one of them minus the other. And it doesn't matter, again, in which order you do this. So just pick whichever one you want and go for it. Obviously, you might pick one over another if it makes things easier, if it makes the math easier. But since you've got all these negatives floating around, you might as well just jump in and go, all right, it's going to be negative 4, right, that's my first y, minus a negative 6. All over, well, since this was my first y, this has to be my first x, so negative 6 minus 3. Okay, negative 4 minus a minus, that becomes a plus. So now it's negative 4 plus 6. On the bottom, negative 6 minus 3, that's just negative 9. Now on the top, negative 4 plus 6, that's the same thing as just 6 minus 4. That leaves us with 2, and we still have a negative 9 on the bottom. So our answer is negative 2/9. Normally we don't leave the negative in the bottom of a fraction. We either put it out in front of the fraction, or we would write it as negative 2/9 with the negative on the top. It's just kind of the grammar equivalent for math. Okay, so this is our slope. Now we have a slope and we have 2 points. We only need one, and we're good to go, right? We've come to that first step. I'm just going to pick this point, and the only reason why I'm going to pick this point over the other point is it's got one less negative number, and I know how much we hate to deal with negative numbers. Okay, where do we go from here? Well, you use the point slope equation, and the point slope equation is y minus y1 equals m times x minus x1. Now, if you can't remember this equation, that's fine. If you can remember y equals mx plus b, then guess what? You can do the same thing with this equation. Plug in your y, plug in your m, plug in your x, solve for b. With this equation, it saves you one step, literally one step. So it's not the end of the world if you can't memorize this equation. Okay, so with this equation, we have y minus, see, the ones with the ones are the ones that actually are our numbers. So we have minus this number, right? So again, we're subtracting a negative, so it's minus a minus 6 equals negative 2 ninths, because that's our slope, times x minus 3, right? Because in this case, our x was positive. Just like before, the minus minus becomes a plus. And now we have to distribute, and we get negative 2 ninths x, and then negative 2 ninths times this negative 3 becomes positive, and when you do a fraction times a number, and we'll do it over here on the side, negative 2 ninths times negative 3, right, is going to be just 2 ninths times 3, because those negatives cancel, but it's really 2 ninths times 3 over 1, right? And you can reduce if you want, or just do the multiplication straight across. 2 times 3 is 6, 9 times 1 is 9, and then now you can reduce by dividing top and bottom by 3. And there's your final answer, plus 2/3. Okay, now the last thing we have to do is move the 6 across, because we want this in slope-intercept form, which means we want it in y equals mx plus b form. Move the 6 across, y equals negative 2 ninths x plus 2/3 minus 6. And now we have to combine those two things for our b, right? That becomes our b. Okay, so over here I'm going to do it on the side again. 2/3 minus 6 is the same thing as 2/3 minus 6 over 1. Now we need a common denominator, so I'm going to come along and multiply this thing top and bottom by 3, right? 3 over 3, because that's just 1. And that gives me 18/3. And now 2/3 minus 18/3 is just 2 minus 18, which is negative 16/3. Check to see if that reduces. It doesn't. And so our final answer is y equals negative 2 ninths x minus 16/3. That is slope-intercept form. Okay, what about standard form? Well, standard form is just ax plus by equals c, where a, b, and c are all integers, whole numbers. But it's the same line, right? So it's the same equation. So all you have to do is take this equation and make it into this form, i.e. have your x's and y's on the same side of the equation and get rid of all fractions. Okay? So if we want to get rid of these fractions, the easiest thing we do is just multiply by the bottoms. And if we have more than one fraction like we have here, the best thing to do is multiply by the bottom of the biggest one. So if I multiply everything through by 9, I know it's going to kill off this first fraction. It might also kill off this one, and in fact it does. So if I multiply everything through by 9, I get 9y equals negative 2x, right? Because when you multiply by 9, those cancel. And then minus, I'm multiplying this, remember, by 9, not 9 over 9, 9 over 1. And these cancel, and it becomes a 3, and now you're just multiplying by a 3, and 16 times 3 is 48. Move the 2x over to the other side, and you have 2x plus 9y equals negative 48. And that's it. That's standard form. And that's some good practice with subtracting negative numbers.